mentioned, I work in product marketing at Dataiku, and I'm going to help bring what Catalina just kind of introduced to us to life by bringing it down a little bit to the ground floor and talking about some of the architectural considerations to keep in mind as we move into this new normal of LLM-powered applications everywhere. And so just to recap kind of the two things that I want to have you bridge into this talk, the first is we saw how, the inside of how one LLM-powered application, that sales performance agent, could look, and the difference between the current processes and what happens inside that agent. And we also learned at the very end there that to stay competitive, companies are going to need to really roll these out across the full spectrum of their business. And there's not going to be one or two, there's going to be dozens, or in larger companies, hundreds of these types of kind of micro apps that serve our needs now. So what we haven't talked about is practically how to do that, and what are the components that you're going to need from an architectural perspective. And that's where I'd like to begin. So if you imagine a framework with 4 levels, we have the data layer, the services layer, the logic layer, and the application layer. Okay, this is conceptual. And let's work our way down to the bottom, starting with these familiar blue boxes: structured data and unstructured data. We've been working with these forever. And we, as we know now with LLMs, unstructured data has a larger role to play than ever before. Somewhat controversially, I'm also going to place the LLMs at this layer, and some of you are not going to like this. But let me explain why, for the purposes of this talk, why we put it here. If you know a little bit about the way these large language models work, there are billions of calculations of parameters that govern these micro calculations inside these neural networks. And when it comes down to it, it's just numbers, right? And they have to be stored. So if you think about some of the largest models, maybe let's say Llama 3 from Meta, or some of the new vision language models, we're talking about 100 billion parameters. It takes 200 gigs to load this model and terabytes to store it. So if you choose to self-host, if open source models are your path of choice, somebody's going to have to store these. So we're going to place them at the data layer. Now, practically speaking, we expose these mostly as services. And so we move up into the services layer, and as I mentioned, if you're hosting your own models for privacy reasons, or you want to fine-tune them and own them, you can maintain the quality of those services over time. That's your responsibility and your choice. Or you can pick from myriad of hosted AI services from people like OpenAI, from Mistral, from Anthropic, from all the major clouds. Okay, just call the API, get the answer. Alongside the LLM services are retrieval services, kind of related. We use a lot of the same type of LLM technologies, but for the purposes of information retrieval. And so if you've heard about retrieval augmented generation or RAG, this will be a familiar concept to you. We also have very familiar actors, data querying services, and for this, almost just think of it like your SQL databases. Standard SQL type work here, and we also have all the arbitrary API services that you can call. Now, those two last components in the new world manifest as tools. And you hear this term, it gets thrown around a lot, but when I think of a tool, it's really a small piece of logic that uses data querying and API services to perform some tasks. So maybe your app has to dynamically look up the weather, or check the traffic, or the stock market before it can make a decision. Or maybe somebody asks a question and you need to go look something up in the customer database before you can then recommend the next best action. So your tools are arbitrary, they're defined in the logic of your application. And so in the logic layer you have these tools, and you also have prompts. Now, if you're not familiar with prompts, it's essentially the logic and the context that you provide to one of these models to tell it what you want it to do and how you want it to do it. Okay, so this is if you're like telling your child how to do it, the prompt is really important. And it's no different with models. And this is really an exciting area when we talk about the creative destruction. All morning I've heard about taking jobs and things. We've heard about prompt engineers. This is a new role. It didn't exist 5 years ago. So not only are we going to have new job functions, we're also going to have new layers of asset management, because teams are going to have hundreds of prompts that need to be tested, developed, governed, maintained, stored, templated for reuse. This is a whole new type of knowledge management that we have inside the company now. All these things come together in an agent. And you can think of this as kind of the combination of the logic that governs what the app is designed to do and the components, the reasoning behind how you use the stuff under the hood. Ultimately, all of this gets hidden, ideally, from the end user. It's just an app, which we all have on our phones. We're all really accustomed to using the app, the front end, the reporting capabilities, all of that. So if you look at what we have on this slide, this is an example of a very simple but kind of canonical LLM-powered application. Certainly a lot of traditional elements, but also, as you see in green, some new ones as well in the IT architecture landscape. Now, throughout the years, there have been a lot of different types of architecture paradigms used to develop apps. In the beginning, monolithic architecture, everything self-contained, and this is really perfect for POCs, right? Everything is self-contained. It's a modular thing that you can kind of just test out. Over time, though, organizations realize that this is a little complex, doesn't scale super well, it's hard to adapt. So we moved into a more modular, services-oriented architecture. And this hung around for a while with XML kind of breaking up the monolith. And now we live mostly in the microservices realm, right? We use JSON to pass data back and forth between microservices, which are mostly sitting on Kubernetes, right? Running on Kubernetes. So it's really simplified things a lot for us. If we think about where we are today with GenAI, not surprisingly, we're back in monolithic land. We're building these huge applications that are sitting on frameworks like LangChain. I mean, admittedly, they're cooler because we call them chains, but it's the same thing. And they're really great for prototyping. This is not to diminish this standalone code block, because you can get up and running with a proof of concept really fast. You can see what's possible, test the boundaries. But it doesn't really scale well. And in 3 to 5 years, it's not what the most successful companies are going to be doing. You're going to have to build a lot of apps. And if we think about what that one application looked like, and then you imagine, oh, somebody saw that and said, well, we should do that not just for sales, but we need this for HR, and we need this for legal. And everyone's got an idea, and you pull the best pieces from another app, and all of a sudden you've got this kind of interdependency that becomes quite hard to maintain. And the technical debt starts to really freak people out, understandably. So it's ugly, for sure, but it's also a little difficult and risky to maintain. Now, a different diagram than Catalina showed, but if you imagine the number of applications that you can build on the x-axis and the complexity of building and maintaining them, it's not quite linear, because as we saw in that last mesh diagram, once you have these interdependencies, it starts to really add complexity in a way that's unsustainable. And so every company has some threshold for chaos that they can tolerate. And at some point, you're going to hit the point where the staff that you have can only do so much because they're spending so much time holding up the earth that they have no time to innovate new stuff. And the only way to move up this curve is to raise that bar. And to do that, we have to break it apart, break the monolith apart, make things more modular. And so this really shifts us into what we consider the LLM Mesh. And this is an architecture paradigm that has really 3 main principles. The first is an abstraction layer that decouples the application from the components that drive it. And this is super important now when we're in this really nascent period, because the best technologies today are not the best technologies 2 weeks from now. And I don't even exaggerate when I say that, and I think you know that. It's moving really fast, and if you hard code things in, it's going to pass you by. So we need to be able to unplug and replug to the next best thing without breaking the whole user experience. Next is Federated Services for control and analysis. So unlike traditional ML, these non-deterministic models are a little bit more unpredictable. You might ask a question that you think is simple, and you use a lot more tokens than you thought. So it's really important that companies can get a hold on things like cost, They can moderate content, make sure there's not toxic content, private information being shared, and all the apps you'll need will need to apply these guardrails and controls. And third, I feel like as we begin, when you're setting up a new house, you think, oh, I'm gonna start off as I mean to go on. And this is really about good housekeeping and hygiene. So having good cataloging, good discovery of those components is really important as you start, because humans who are building them need to know which pieces are the right ones to pull for their app. The end users who have that catalog of apps at their disposal need to know which URL or which app to click on that does the thing that they need. And the AI agents themselves that are working somewhat autonomously are going to be reading the metadata that we put in about each of these components to know what it should be querying. So this hygiene really serves a lot of purposes. So taken together, this is really our vision for how you go from that LLM mess to an LLM mesh. First, you start with your shared catalog and gateway. And this is where you put all the different access controls around the objects you're going to be building with. They're documented, they're approved, it's registered for use. And then you build out your federated services. And this part's really important. What are your security and access rules? What type of policies do you have on content moderation? What types of models are allowed to work with your sensitive data? Maybe it's an offline model, open source for all of our sensitive stuff, hosted for stuff that, for marketing, stuff that we want to get out anyway to some extent. So in the event that the terms of use aren't what they say they are, we're protected. Those are the types of conversations we're having. Cost is a big one. Cost is a big barrier, and finance does not like surprises. Performance measuring. This is a big one that I'll talk about later this afternoon in the product talk, where I talk about how you measure LLM quality beyond looking at 5 or 10 and going, yeah, that seems right. That's pretty good. That's good for a prototype that doesn't work at scale with millions of transactions. Once you have those things in place, your builders can go and build, and you know that they're kind of playing in a safe playground. We've put up the guardrails. So you could build that yourself. As Cataline mentioned, if you have the know-how and you have the vision, you can build it yourself. But this is a concept that we've been thinking about for a while, and we came up with it a couple of years ago, so much so that you could actually say we're writing the literal book. One of my colleagues, Kurt Mumel, is actually kind of partnering with O'Reilly to write this book about the LLM mesh paradigm, and I definitely encourage you to scan this QR code. You can read chapters 1 and 2 already. I think the next one will be ready, 3 and 4 will be ready before the end of the year, and then the whole technical guide comes out early next year. So this is a fast read. It's kind of like a primer and a guidebook all in one. Go there to learn more, and then not surprisingly, we're a software company, so of course we have the LLM mesh inside Dataiku. Again, at 3 o'clock, I'm really going to break down everything you see in this slide and translate it into what the product features are that make up these components. But suffice to say that you should feel reassured that all these things are already baked into the product that those of you who use us hopefully know and love. And so you can get started with incorporating GenAI into your existing workflows pretty much seamlessly. You don't have to buy new software. You don't have to upskill in a new UI. You don't have to do a big integration and migration. It's all just recipes, components, code stuff, visual stuff that you would expect from Dataiku. So with that, I'll close a little bit early, try to get us some time back, and thank you so much today, and I look forward to speaking with you more about what's coming and what's new in the product at 3 o'clock. Thanks.